Hey geometry students, you are following along with the lesson 7 guided notes. This is the last lesson in the unit about three-dimensional shapes. You should be in your workbook on page 145. We are talking about similar solids, which is the first blank on page 145. Excuse me. Similar solids are solids, three-dimensional things that have the same shape, but just like when we talked about similarity in January, they're not the same exact shape, so their corresponding dimensions are proportional. It's been a while since we've talked about that, but proportional would be when you have two fractions that turn out to be equal. So if I put like some number over 6, if that some number was the number 3, then they're proportional because then the fractions would be equal to each other. So that's what we're looking at here with these two. Well, the question is if these two similar cylinders are similar. To determine this, we need to find the similarity ratio. We need to find the fraction of corresponding parts to see if they're the same fraction, to see if they're proportional. So I'm going to pick corresponding parts. I'm going to start with looking at the radius of the larger cylinder, and I'm going to put that over the radius of the smaller cylinder. It's fine to put large over small, but just keep in mind I'm stuck in that order. Whatever you start out with, you have to stay with. So I need to pick a different number from the large cylinder. There's only one other one, the height. And I'm going to put it over a corresponding part of the small cylinder, the height. Now the first fraction was already reduced, so I just kind of left it as is. This one, both 12 and 10 can be divided by 2. Which means they both turn out to have a ratio of 6:5. So the question was, are they similar? The answer is yes, they are similar. The similarity ratio is 6:5. Now we didn't ask the order, excuse me, of the similarity ratio of large to small or small to large, but they are similar for sure. So now on number 2, these solids, I'm wanting to know if they are similar. So it's the exact same test. So I'm going to pair up corresponding parts. Personally, I'm going to start with the heights, and I'm going to put 3 over 6. When I reduce that by 3, I get a half. I'm going to pair that with the front portion of the base, 2 to 4. When I reduce that, I get a half. And that'll finally be combined with the depth, which is the 1 to 2. Since those all have the exact same ratio, that is my similarity ratio, these are similar solids. Their similarity ratio is 1 to 2. Because they're similar, the whole point of what we're looking at this section is about these relationships that come about whenever you have similarity. Now, one of the properties has to do with the surface area. Now, we have not talked surface area literally once this entire school year. And it's because it's technically supposed to be a middle school topic, but for most of you, middle school was a real long time ago, and you probably don't remember a bunch of it. So when I'm talking about surface area, it's literally the area on the surface. So if I had a present that was this size and I had to wrap all the surfaces, it's how much wrapping paper I'd need for every surface. Meaning I need to cover this area. Well, this area is a 2 by 1 rectangle. So this part has an area of 2. But since this happens to be a prism, I have 2 of that exact same base. This is also 2 by 1, which means not only do I have, excuse me, every time, not only do I have that 2 by 1 base on the bottom, but I have the exact same 2 by 1 base on the top as well. So I have 2 of these, but that's not all of my surfaces. I'm going to next look at the ones that I consider on like the left and the right. The right side is a rectangle, but it's a 3 by 1. It's 3 high and 1 deep. So it has an area of 3. But this left rectangle is also 3 by 1. So there's another 3 by 1. Rectangular prisms don't just have 4 sides though. They have 6 sides, so I'm missing a side. Specifically, it's going to be hard to see. Let me erase all those marks. Specifically, the one on the front. I have not accounted for this one. This one is 2 by some number that's technically not labeled, but it's the height of the shape, so it's 2 by 3. The area of the front of this prism is 6, which means if I go to find the area of the back of the prism, it's also 2 by 3. There is a nice formula for using this. Theoretically, you learned it whenever you were in middle school. Theoretically, you forgot about it since then, so we just won't use it. But if I have all of these surfaces, I can find the total surface area just by adding my individual surfaces. So what would I get? There'd be 3 6s, 18, 19, 20, 22. 22 square units for that smaller one. And it's square units because it's the surface area. Area is always in units squared. Then technically I need to do the exact same process for my other shape. I need to consider the bottom, which is where I start on the other one. The bottom of this thing is a 4 by 2 rectangle, so it has an area of 8. The top is also a 4 by 2 rectangle, so I get another 8. Then I looked at the left and the right sides. The right side is this rectangle. It's a 6 by 2. It has an area of 12, which means the left side would also be a 6 by 2. I get another 12 units. And then finally, if we go to the front and the back, this is when I would go erase all that. The front is 4, and then the height we said earlier was 6, so it's a 4 by 6. You're not going to have to do this process, I think, ever. That's why I'm just kind of quickly talking through this. 6. So again, we have all these individual areas. If I want the total surface area, I just need to sum all those surfaces areas. So I'd have the 2 8s, the 2 24s, and the 2 12s. So I'm getting 88. We'll look at the relationship in a second, but right now I'm just finding these things. Volume of each prism is not something you should have done in middle school. It's something that you should have done when we talked lesson 2. However, we'll go through it anyway. You take the area of the base, whatever shape it happens to be for a prism, times the height. Since these are rectangular prisms, it's the really familiar formula, length times width times height. So for the smaller shape, that's the 2 by 1 by 3. So we get 6 cubic units. And for the larger shape, we would have 4 by 2 by 6, which is a number 48. So now I have all this information. I know the ratio of my sides because I already made you do that. That's the similarity ratio. That's the answer to part D. That is not the same ratio you'll get for the ratio of the surface areas. The surface areas are what we did on part B. So if I take the surface area of 22, put it over the surface area of 88, if I put that in my calculator and reduce, or if in my head I divide both of those by 22, I get 1 to 4. So similar to a half, but not the exact same thing. And then if I take those volumes I just found and write a ratio of those, 6 to 48, when I reduce that, I get a completely separate ratio. But these are related ratios. So what we end up seeing is that if I have some starting out ratio of A to B, like this 1 to 2, I can quickly find the ratio of the surface areas by just squaring A and B. 1 squared was 1, 2 squared was 4. I can also quickly find the ratio of the volumes without actually calculating them, because I could take my initial A and B and take it to the third power. 1 cubed is 1, 2 cubed is 8, which should kind of make sense with this relationship of what we were doing. When I find volume, I'm multiplying. Actually, let me start over. When I went from 2 to 4 at the very beginning, 2 to 4 was our relationship of half. I have a shape that's twice the size of the other. So 2, if I take twice it, I get 4. 1 times 2 is 2. 3 times 2 is 6. So I'm taking my original volume and multiplying it times 2 times 2 times 2, which means I'm taking it to the third power. So that's the reason that this relationship exists. What it means is we don't have to be given shapes at all, and we can find a bunch of ratios. Because again, the similarity ratio is always like home base. It's the A to B. If you take those two numbers and square them, you'll have your ratio of the surface areas, which means for this first one, I would be thinking 2 squared and 5 squared, which is just 4 to 25. But if you take those initial first two numbers again, the A and the B, the home base, the similarity ratio, and you cube them, you'll get your ratio of your volumes. So now I'm talking 2 to the third power, 5 to the third power, which would be 8 to 125. I don't know any of the volumes, but I do know what their ratios would be. You can also use this to work backwards. In the second row, I'm giving you the ratio of the surface areas. I'm giving you what has already been achieved by squaring. So I just want to undo that. I always think of this column, my similarity ratio, as home base, because I need to either be given it to start out with, or I need to find it in the first place to go other places. So if I know that a squared is 9, the square root of 9 gets me 3. If I know b squared gave me 100, the square root of 100 gets us 10. That similarity ratio had to be 3 to 10. And now that I have home base, I can get to the other locations by not squaring this time, but cubing. So I'll take my initial a and b that we just found, and I'm going to cube them. 3 to the third power, 3 times 3 times 3 is 27. 10 times 10 times 10 is 1,000. However, on this last row, I'm not trying to get to the ratio volumes. I'm already here. I already know what happens after I've cubed those numbers. So I'm basically reversing it. I don't want to go that way. I'm trying to get to home base. Square rooting will not help because these numbers have not been squared. They have been cubed. So similar to the sphere section, we need to undo cubing by cube rooting. That is not the symbol I meant to draw. Cube rooting. So 3 kind of wedged inside the square root symbol. So I need the cube root of 8. I need the cube root of 729. I'm hoping by now you either asked your teacher how your calculator worked if you weren't able to Google it and figure it out yourself, but most scientific calculators should be built with this feature in it. So it is possible for you to put it in your calculator. But if I take the cube root of 8, I get 2. If I take the cube root of 729, I get 9. Once you have home base, you can get to the others by either squaring or cubing, depending on what row you're looking for. Surface area is that initial similarity ratio squared. So that means 2 squared and 9 squared. So that ratio would have to be 4 to 81. What a lot of the practices are going to look like, meaning the IXLs, these images were pulled off of IXL. This is how IXL is going to ask these questions of you. So they're going to tell you they're similar. This is very important. If they're not similar, then you can't do anything. If they're not similar, you don't have a similarity ratio. Start with your similarity ratio, which means find corresponding parts and write a fraction. In these two cones, we have the radii. So I'm going to put 3 to 2. That's home base. I can get to the ratio of the surface areas and the ratio of the volumes by squaring and cubing those numbers. So if I take 3 squared, I get 9. If I take 2 squared, I get 4. But if I take these original two numbers again, but this time cube them, 3 to the third power is 27. 2 to the third power is 8. These are just the ratios, though. I want to find a surface area. If the question is asking about surface area, you have got to use the ratio of the surface areas. This is basically saying if I put big surface area over small surface area, it reduces to 9/4. So that's what I'm going to do. I'm going to put big surface area over small surface area. Number I don't know over 36 is going to have to be this ratio of surface areas of 9 to 4. And by now we should be semi-decent at solving proportions. I'm going to cross multiply, and I get 324. And when I divide by 4, I get 81. So 81 square inches is that missing surface area. But the directions for the IXL are not going to ask you to find all of these ratios, and you're going to get stuck unless you come back to your notes here and make yourself go through all these steps. Start with basics, start with home base, find your basic similarity ratio. The two corresponding parts here are an 8 and a 6. I'm going to reduce that because anytime you write a ratio, you should reduce it, and it's going to make your calculations a little easier. But once I have home base, I can find the others by squaring those numbers, 16 to 9. I can find the ratio of the volume by cubing those original numbers, 4 to the third power, 4 times 4 times 4. I'm pretty sure 64. Let me double check that. Yep. 3 times 3 times 3 is 27. I don't need all of these fractions. I need one of them to find, this is a typo, this says surface area. If you actually look at what's asked for, it's talking about volumes. So that should say find the missing volume. IXL won't have a typo. My notes have typos. But if I'm looking for volume, the only thing that's useful is the ratio of the volumes. If I put large volume over small volume, it turns out to be 64 to 27. So that's what I'm going to do. I'm going to put large volume over unknown small volume, which you 100% could cross multiply and solve, but pay attention to what I just wrote. 64 over 27 is the same thing as 64 over some number. That number's going to be 27. Or if you aren't paying attention, you're going to cross multiply and solve. It'll still be 27. So the number 6. The volume of two similar solids are these two numbers. It was calculated, we found them. The surface area is this number. We're finding a surface area. There's no picture. There's no way you can say, here's the formula I should use. This is all about these similar solids. If they're similar, write yourself proportions. Everything you've ever done in this class about similarity has hinged on proportions. That's what we're going to use. I'm going to start with the fact that I'm told two volumes. So I'm going to write the ratio of the volumes, 128 over 250. I'm going to make a note that these are my... I'm going to put volume 1 over volume 2, just so I remember that these are volumes. And those are even numbers, so I'm going to reduce them. And I got 64 over 125. Now again, this is the ratio of the volumes. This is not your similarity ratio. This is not home base. This would be as if on that other page, me giving you this right-hand column, me giving you these numbers, which we don't want. We want home base. To get to home base, you either square root or cube root. And if you're talking ratio of volumes with these cubed values, you're going to be cube rooting. So this is basically saying this is some number cubed over some number cubed. If I would like to undo that, I can find my similarity ratio by cube rooting 64 and also cube rooting 125. So what number times itself 3 times is 64? Well, we actually already used this one earlier. It's 4. We used the cube root of 125 as well. It was 5. This, again, not the answer. The question is wanting a surface area. If you're needing a surface area and you have similar shapes, you need the ratio of the surface areas. So I don't need the one with the cubes. I don't need this home base one with the exponent of 1. I need the one that has been squared. So I'm going to square the 4 and I'm going to square the 5. This is ratio of small surface area to large surface area. So this is saying, what's the surface area of the smaller solid? I don't know what was put on top, but the surface area of the that says larger solid is 250. So the bottom would be 250. This is essentially what I'm doing is, without as much organization, I just filled out like the bottom row here. So I used this row to find home base. I used home base to find surface area. I'm now combining that with what we did on the last question where we're writing a proportion to find what's missing. That's what this step is. So I'm going to solve this proportion to find the smaller surface area. I'm going to do it over on the left here. 25 times x and 16 times 250 when I solve by cross multiplying. So I'm getting 4,000, which is 160 when I solve by division. There's a lot of steps here. You could, if that organization here made more sense, which I would imagine it probably does, that's why I added in to the notes, by all means use that to answer these questions. So think, let me use another color. So think we can talk similarity ratio, we can talk ratio of surface areas, and we could talk ratio of volumes. We could be given any of these three things and find what's missing. But I'm telling you the surface areas. So I'm giving you this middle column. This problem, though, only asks for the similarity ratio. It just wants home base. To get to home base, I just need to knock out these squareds. So I will square root 144, and I will square root 324. But because I would like full credit, I will not leave a fraction unreduced. 6 divides into both those. 2 to 3 would be my reduced ratio. You'll notice we were never asked anything about volume, so I just am not going to do anything with it. Almost done. Last question. Similar cones. The moment you see similar solids, we're going to use some proportions. It says the ratio of the corresponding diameters is equal to the ratio of the corresponding heights, which is another way of saying, hey, these things are similar. So if I'm looking for just a missing height, this is exactly the same as what we did in January. You could essentially ignore the fact that we have a cone and just think, hey, look, these triangles are similar. Find the missing height. That's essentially all this problem is. It's just that a lot of us forget that you could do that by this point in the semester. So I know that the radius can be paired with the radius. I know the height can be paired with the height. So I can just cross multiply. So I can find that my missing height is 6 meters. If I want the ratio of the volumes, I could absolutely find those. Personally, I don't really want to, because as long as I know one of my similarity ratios is 4 to 3, this is knowing home base. If I want to get away from that, I can find the ratio of the surface areas, which I don't care about, and I do care about the ratio of the volumes. I'm just going to cube those numbers. 4 times 4 times 4 is 64. 3 times 3 times 3 is 27, and I guarantee that's faster than you going back through your notes, looking up the fact that the formula is 1/3 pi r squared h, putting that in your calculator, well, actually figuring out first what you're plugging in, not making mistakes, getting your answer in terms of pi. You're going to have a fraction, putting a fraction in terms of pi over a fraction in terms of pi, and then hoping that you can reduce it to this. Using this is so much quicker if we happen to just want the ratio. So that should be it. This is typically one of the more difficult lessons to get through. So if you have questions, make sure you're emailing your teachers. But first and foremost, go wash your hands. This is your reminder that, hey, you